Okay, so what we want to do is, now we have a chain of matrices A1, A2, A3 up to AN, and this is the convention you're going to follow for the dimensions. So the matrix index, so A1, so that matrix you're going to say its dimension is P0, 1 less than that index 1, which is 0, so P0 times P1, so it's a P0 by P1 matrix. So this is the number of rows and this is the number of columns. And for A2 it is going to have P1 rows and P2 columns. A3 is going to have P2 rows and P3 columns. So that's the convention you're going to follow. So AN is going to have Pn minus 1, that many rows, and Pn, that many columns. Okay, so you know by now, so if you had three matrices like we just did in the previous example, there are two ways you can do what's called parenthesize them. So we can parenthesize A2 and A3 first and then multiply A1 with the result of this product. Similarly, we can parenthesize A1 and A2 first and then multiply the result with A3. So now think about how many ways you can parenthesize this chain. There are several ways, right? You could do A1, A2 first and the result multiply with, say, you could do either A3, A4 in parallel and then A1, A2 multiply with A3 and A4. So there are a lot of ways. So it's like exponential number of ways if you want to try the brute force approach, right? So that's why we don't want to try all the different options with brute force. We want to do a dynamic programming approach to find out the minimum number of multiplications, and the best way to what is called parenthesize this chain so that we minimize the number of multiplications we do. Alright, so that's the problem. So the thing is, for any dynamic programming problem, we have to identify this optimal substructure. So that means given a chain of matrices AI to AJ, how we parenthesize that substruct chain. So some chain starting with AI and ending with AJ. So what we have to find is that K where we can stop in between. Okay. So this chain is from AI to AJ. So we want to parenthesize them instead like this. We have to multiply everything from AI to AK and then everything from AK plus 1 to AJ. So multiply this subchain and this subchain. So AI multiplied up to AK, we are going to get one result product matrix. Then AK plus 1 multiplied up to AJ, we are going to get one result product matrix. Then once we get these two product matrices, we have to multiply those two and get the final answer. So the issue is at what K we should parenthesize from AI to AJ, so that we split that chain AI to AJ to two subchains, where one subchain is from AI to AK and the other subchain is from AK plus 1 to AJ. So what is that K where it should be split? So what I mean is this, like in this example, let us say this is the overall A1 to A8, right? So that is like A1 up from A1 to AN. Now we have a subchain which is like A2 to A7. So this is what is a AI to AJ. So if this is my AI, A2, and then A3, A4, A5, A6, A7, that's my AJ. So where should I split this chain such that I multiply the two subchains and multiply the resulting subproduct matrices? So in this case, I pick my K as 4. So I'll do A2, A3, A4, that is one subchain, and A5, which is K plus 1, and then A6, A7. So I multiply these and get one product matrix, multiply these and get one product matrix, and then multiply these two. So here my K is 4. So if I do with K as 4, I'll have to do some number of multiplications. Now I could do K as 3. In that case, I'll do A2, A3 is one subchain, then A4 to A7 is another subchain. Then I could do K as 5. I could do A2 to A5 as one subchain and A6 to A7. My K could be even A2. I could just do A2 as one subchain In this case I don't do any multiplication to multiply a matrix with itself, and then I could do just A3 to A7 as the other subchain and go on. So the k values go from I to less than j. So in this case, from A2 to A7, my k could be 2, 3, 4, 5 or 6. So these were the possible k values where I could split this chain to two subchains, right? So now what we are going to do is, how many multiplications we need to, I'm just explaining the recurrence first in general, and as we go through the examples things will become very clear. Okay, so just stay and keep focusing. How many multiplications we encounter, so that's what we have to figure out now. Okay, so this AI is going to be of dimension according to our convention pi minus 1 times pi, right? Because any matrix with index I, its dimension is going to be 1 less than that many rows, pi minus 1. That's the index for the number of rows, and then pi for the columns. Then ak is going to be pk minus 1 rows and pk columns. So if we keep multiplying them, ai to ak, the resulting product matrix is going to be of dimension pi minus 1 times pk. Why is that? Let us see this example. If I choose say A2 to A4, A2 is like P1 by P2, A3 is P2 by P3, A4 is P3 by P4. So if you multiply A2, A3, A4, it's like what? The common dimension goes away, it's P1 by P3, and again P3 is the common dimension of A4, so P4. So it's P1 by P4. So if you multiply these three matrices, 4 by 5, 5 by 2, 2 by 7, the product matrix is going to be what? All the common dimensions kind of cancelling out. It's going to be a 4 by 7 matrix between A2, A3 and A4. That's 4 by 7. So that 4 comes from A2's row, which is P1, and the 7 comes from A4's column, which is PK, right? So when you multiply AI to AK, the product matrix is going to have dimension PI minus 1 and by pk, the number of columns. Similarly, ak plus 1 to aj is going to be like ak plus 1 is of dimension pk by pk plus 1. aj is going to dimension pj minus 1 and pj. So if we keep multiplying from ak plus 1 to aj, the product matrix is going to dimension pk, the first one, the row here, and the column here, which is pj. So that's going to be dimension of pk and of this product matrix, pk times by pj matrix. So now if you multiply these two subchains, ai, ak is one product matrix, ak plus 1, aj is one product matrix. The resulting product is going to be of dimension pi minus 1, and the pk is the common dimension here. And so pi minus 1 times pj is going to be the dimension of this product of this chain from ai to aj. So now what is the number of multiplications we have to encounter? To multiply from ai to ak, let us indicate m of I comma k is the number of multiplications to multiply from ai to ak. That's the number of multiplications. To multiply from ak plus 1 to aj, let us indicate m of k plus 1 comma j as the number of multiplications. Now this is the number of multiplications to multiply this subchain. This is mk plus 1 comma j is the number of multiplications to multiply this subchain. Then to multiply these two product matrices, which are of dimensions pi minus 1 by pk and pk by pj, the number of multiplications we do is pi minus 1 times the common dimension pk times pj. So this is to multiply the product matrices. So for example, if you are given from A2 to A7 and your k is 4, so A2, A3, A4 is one subchain, A5, A6, A7 is the other subchain. So you indicate m of 2 comma 4 as the number of multiplications to multiply from A2 to A4. m of 5 comma 7 is the number of multiplications to multiply from A5, A6 up to A7. plus the number of multiplications to multiply these two product matrices. So as I said, A2, A3, A4 is one matrix, the product. Then A5, A6, A7, the product is one matrix of these dimensions, 4 by 7 and 7 by 3. Then to multiply these two matrices, you would do how many multiplications? 4 times 7, the common dimension, times 3. So that is Pi minus 1, Pk and Pj. So this is for a particular k. So in this chain from Ai to Aj, you split that chain at k. In this case, k is 4. From A2 to A7, you encounter this many multiplications, Mik plus M of k plus 1 comma j, and this Pi minus 1 Pk Pj. So a k could go anywhere from I less than equal to k to less than j. So you could split. So these are possible k values. So like in this case, in this example that we just did, so in this case k is 1. So you split as k is 1, you multiply a1, k is itself, and then a2 and a3. And here k is 2. So you split that chain a1, a2, a3 at 2, multiply a1, a2, and this is a3. So these are the two possible k values. K is 1 here, k is 2 here, and we got totally these many multiplications. We pick the minimum. So in general, we try different possible values of k from I less than equal to k up to less than j, and pick the minimum of the total number of multiplications we encounter. Like we pick minimum of 60 and 94. And that's the minimum number of multiplications to multiply from ai to aj. Okay, so this is like the recurrence. Now we do this if I is less than j. If I is equal to j, that means it's just one matrix. So if it's just one matrix, we don't need to multiply with anything. So the number of multiplications we encounter is 0. So if I equals j, there's just one matrix, so we don't need to do any multiplication. So only if I is less than j, we have to consider the different values of k and find the number of multiplications you encounter for each value of k using this recurrence, and then pick the minimum. Okay, so that's the recurrence relation, and now we'll start looking at the numerical problems. Things will become very easier now. Okay, let me stop for a second and save this video.